Now we are going to talk about the plots, how plots are generated in R. So there are multiple types of plots, and plots are associated with different features like x-axis, y-axis, the name of the plot, colors, then edit with the dot, the connecting lines. So that's all we are going to discuss here. So the first is the line plot. We are going to talk about the line plots. So essentially for line plots, we need some value. So here we are creating a, a vector called cars, and for that there are some user specified value, that is 1 3 6 4 9. So these are the value been specified. Like there is a object called car, and that is created. Now we are going to plot. We are essentially talking about a line plot. So we're going to draw a line plot. So for that, the function is plot. By help of plot, we can plot a line plot specifying the object. So here my object is car, and using the function plot. The moment I run it, a plot is created here. So this is how the default behavior of the plot is, wherein my y-axis is the values which I specified, like 1 3 6 4 9, 1 3 6 4 9. So this is coming like this. So that is the default plot, wherein we are specifying only the dimension, one dimension. So in that case, y-axis is my default dimension, and x-axis is taken as an index. So those indexes are not very relevant. Reason being, it talks about the element. This is first value, this is second value, this is third value, this is fourth value, this is fifth value. So it only talks about the sequence of the value, the way it comes to the data. Now I'm going to plot the same thing here, but I am adding some more and more option. So what exactly I'm doing? I'm using the plot function, specifying the object, and I'm saying type is equal to O. O is what? It's the overplotted. That is, I'm connecting these dots together. So this is called the smooth lines. I'm creating something called smoother. It's not smooth, but this is the connecting lines. So type, so there are multiple options we have. So if I replace, like here, in this case, this is line, connected line which comes in. So for connecting the lines, we use this type option. The moment I replace this type with P, so I will get only the points. There is no lines. Fine. So we have multiple options. If I replace it with L, I will get only the lines. There is no points. There is no dot. So we show all three options. So O is what? O is basically a combination of line as well as point. But if we are specific about only the points or only the lines, so we can specify. The moment I replace it with H, that is a histogram kind of structure, so I will get something which comes as histogram, that is bar, that is length of each and every value is given here. So we have multiple options in that. Now we are going to create something to add some title with the plot, some colors, some font. So I'm saying that plot, to that the plot which we have created, on top of that I'm saying main is equal to autos. So main is equal to what? Is the name of the plot. So auto will come here as a name, that as an index, as a header. It says that the name of this plot is auto. I'm saying color of main is what? It's red. So the font of this auto will come in red color. Now I'm saying font dot main. So here I am specifying the size, that how big it should look like here. So main is what? It's the name of this plot, or you can say the lesion which we associated with the plot. The color dot main, that is col dot main, is what it talks about. The red, if I replace it with blue, so we'll get in the blue color. So that the blue color has come. Now the font dot main is what basically it is talking about the font size. So there are predefined font size in R. It's not essentially like Excel wherein the font the numbers are directly correlated with the size of the fonts. Here it is true in some cases, but it is not true in each and every case. So for more information about font, you can go to the help directory and we get information about the font being used in R. So essentially I am using font is equal to 4. So there are different font size. If I write 3, it will come in some other format. So that essentially we need to understand that what font being used in different cases. So now this is something else. So now here the important thing to understand is, now let me remove this plot. Now this plot is removed. If I run this title will not run standalone. So what is important to understand here, that these titles are on the top of the plot which we created. So for that we need to first create a plot. So now my plot is in place. Now what I'm doing, I'm going to add these titles, everything on top of this plot. So as an essential requirement, we must have plot. So first step is to create plot, then to add title. Now if I write, if I run the title function, so now title is on the top of my plot, whatever I created. Now the earlier example was with one vector. Only information about car was given or auto was given. Now we are going to talk about two different vectors. That is, now we have two different vectors. One is cars and second is trucks. So now essentially what are we going to do? We are going to plot cars. I'm saying type is equal to O. That is overlay kind of plot. I'm saying color is equal to blue. And now I'm limiting my y-axis. I'm saying that what should be the length of my y-axis. I know that my maximum value is 9. So why do I keep it default to be decided by R, that what is length of my y-axis? Why not as a user I specify that the the length of the y-axis should be 0 to 12, not more than 12. So that's what essentially I'm saying. I'm saying that this start from 0 and goes till 12. You can change as per your convenient. Suppose I'm doing it 20. So it will go to 20. But in that case, the moment we increase the dimension of my y-axis, my graph, it tends to go down. Reason being, my highest is 9 in my data, but the scale, essentially it is talking about the scale. but the scale which I'm taking, that is going till 20. That's the reason that in case you want to give a, a good look to your graph, so this y limit is essential. I would suggest in that case rather use 10. That will give you a graph which is very close to the final value of your y-axis. Now the same thing we are going to do with the second vector, that is with the truck. So here I'm plotting again. We are saying that lines, the value is what we are going to do. With the trucks we are going to do, we are saying type is equal to O, and we are there are another option that is called PCH is equal to 20. PCH, it's basically it's a point of shape. Fine. So these are the multiple options available in R, wherein the PCH is essentially talking about the shape of the point. Then we have LTY. It is talking about the line type, that what type of line is. So there are some default line types. Two is for the dashed, one is for the solid lines. So there are multiple types of line. So this is for the line type, that what type of line, because we know in previous case by default my line has come like this line, but now I want to differentiate it. So I'm going to create a dash type of line so that I can differentiate. At the same time I'm specifying some other color so that it both the lines do not look similar like this. So this is the objective. So what exactly I'm doing, I created one plot, and inside that plot I'm I'm inserting uh, a line graph on the value of trucks. This is my vector. I'm saying type is equal to O. That is, I wanted to have a connecting element. Then PCH. This is talking about the shape. So here exactly we are talking about the box. In previous case, this was circle, but here I'm talking about the box. So this is PCS 22 is essentially for the box. If you change it by 20, I'm not sure what will come. So this is how the shapes are supposed to come. So there are different shapes type in R, but the the popular types are 22 and all. So that's what we use. So you can specify your shape type, that in which shape region, being the objective is to differentiate between both the shapes. And then we are talking about the line type. Is it dotted? Is it solid? The moment I do it 1, it will be the solid line. It is a solid line, the way it comes in the previous graph. Now I'm talking about the color is equal to red. Reason being, wanted to differentiate between both the colors. So this is best part of R in graphics, wherein once we create a plot, on top of that plot, you can add more and more number of plots to have a combined impact, or to have a combined visual appeal from the of the different elements. Now we are going to add title with that. So we saw about the title. I'm saying that main is equal to auto, color of main is equal to red, and font of main is equal to 4. So this is how uh, a plot is created with two different vectors. Now we are going to talk about the bar plot. So for the bar plot, essentially we need some vector. So my vector is cars. I am saying bar plot of car. So this is how the bar plot looks like. So as I mentioned in previous case, that we need to be very careful that if we specify a vector which is of course vector is of one dimension, but the moment this is only one now, it's a vector, and you specify either bar plot or line or whatever, the y-axis is taken as the default. So that's what it's saying. It is saying the my first element is of height 1, second element is of height 2. Likewise, it is coming up. First element is 1, second element is 3, next element is 6, then element is 4, and the last element is 9. So accordingly, it takes height of the element and it goes up. So we talk about the line plots. So this is what we created. We define a car vector with 5 values. Then on top of that, we plot specified the type is equal to O, that is the connecting lines, connecting points we wanted. Color is equal to blue, that's what our objective was. Then we added some titles to the plot with the main and color dot main and the font dot main. So these are the options. For the line plot, this is what we saw. We simply we create multiple values together, and we are saying that graph card using an y-axis that range from 0 to 12. So that's the reason that we use the y-lim, that is y-limit, and essentially the type is equal to O, color is equal to blue. These are the previous options were discussed. Now we added more lines. This time I'm using a vector truck and type is equal to O. Then here essentially we're talking about the shape. We're talking about the type of line, that is this is for the dotted line. The moment you change 2 from 1, this will be a solid line. Then we're talking about the color of the line, is it red, blue, whatever you want. Then we added some main and title to the plot. Now this is about the bar plot. The way we saw, we create a vector for that, and on that we simply added a bar plot option. Now in bar plot, we are going to talk about more and more about bar plots. So exactly, we are adding we are doing some value addition in this plot. So my element is, my vector is A. On that, I'm using bar plot. In previous case, we saw the moment we write simply bar plot, it looks like this. A very simple bar plot comes. Now here I'm saying my object is, that is the value on which I'm going to create my plot is A. Main is what? It is a legend, or you can say the name of this graph will come. Now I'm saying xlab. So by default, xlab has no value. But now I'm saying xlab is equal to days and ylab is equal to total. So I'm saying this will be the total value. So here for axis, I'm defining the name. Now here I'm assigning name dot arg. So I'm saying for this value 1, 2, 3, 4, this is 1, 2, 5, 4, 3. I'm assigning value like Monday, Tuesday, Wednesday, Thursday, and Friday. Now I'm saying border is equal to blue. So if the graph is plotted, so what is the border of my boxes? And essentially I'm talking about the density. Density is what? I want to differentiate between different days. So here the density is uniform. I mean, the way this plot, this bar, the color in this bar is the same color is used in this bar. But here I'm saying it's not so. I want different density inside these boxes so that someone can easily differentiate. Let's see the example. This is what exactly I wanted to explain. That I'm saying that I'm creating a plot, a box plot, a bar plot on a vector A. Main is equal to cars, that is coming here. X lab is equal to days, that is here. Y lab is equal to total, which is given here. And now, essentially for each and every element, I am assigning the name. I'm saying this one corresponds to Monday, two correspond to Tuesday. So that's what it is coming here. Now, I'm saying border is equal to blue. That's the reason that blue borders are there. If I say border is equal to red, so we'll get the red borders. So now my borders are red. So this is how this border option is used. Now I'm talking about a density. I'm saying that I want to use different graphics, that the density of the graph of the line which is coming in box, that should be different so that I can differentiate it. So I'm using density 10, 20, 30, 40, 50, so that I can differentiate it. You can change density as per your convenient. Now, essentially this density is being used to focus on certain days. That depends on your priority. Here, I am saying that I am prioritizing my days the way it is going forward. So, so that's how this number's been used now. And this time I am saying no. I am prioritizing 2 days. That is Tuesday and Friday. So I'm using 100 for this. Then third priorities, I'm going to this third element, that is Wednesday. And the last priority is on Monday and Thursday. So the moment I run like this, we'll get likewise density. So here it is apparent that density of Friday and Tuesday is the same, whereas density of Wednesday is next to these two values, and density of Monday and Thursday is the same. That's how you can change the density to differentiate between the different bars. That is to differentiate between different boxes. So likewise, we create an object. In our case, we took example of one case. When we say that bar plot A, that is the value on which this bar plot is plotted, main is equal to cars, X lab is equal to day, Y lab is equal to total. Name essentially we are writing like this. Then for the borders, we are saying blue, red, whatever you want. And density accordingly you can specify. The first example we saw wherein density is written in ascending order. The same thing is written here. But here we are saying color is equal to rainbow. The moment we say color is equal to rainbow, it comes as a very colorful kind of. So it comes as a rainbow colors. So here the different lines being used in different colors. So these are a default option. In case of rainbow, if we see the syntax, I'm saying that border is equal to blue, density is what, and color is equal to rainbow. And why this 5 we use? Reason being, we are saying that there are 5 elements in here, so must use 5 different colors. So we do not have command over here on the color. It takes the random colors, but it tries to differentiate between the color of the different boxes. So that is how the default behavior is. So that's it is talking about the rainbow, and this is all about the introduction of R.